Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 281. Page 281, and today is our lesson number 94. Lesson number 94. There are two problems that I want to solve today. But I'm going to do them in reverse order. Let's first do problem number 75. I want to get problem number 75 out of the way for those of you who do not need any help with 74. That way you don't have to go through the entire video to wait until we get that 75. So you can watch this problem 75 and be done with it. In problem number 75 it says, question is the positive two-digit integer n less than 40? That's all it is. The question simply is it less than 40? In the first statement they tell us that the unit digit of n is 6 more than 10 digits. Well, that pretty much nails it. Because what this tells us is that, what this implies is that the 10 digit, what they have just told you here is that the 10 digit cannot be 4 or more. 10 digit cannot be 4 or more. 10 digit has to be 3, 2 or 1. Why a 3, 2 or 1? Because here's your 10 digit, here's your unit digit. If the 10 digit is 3, because of the fact that the unit digit is 6 more than 10 digit, if 10 digit is 3, the unit digit is going to be 3 plus 6. If 10 digit is 2, the unit digit is going to be 2 plus 6. If 10 digit is 1, the unit digit is going to be 1 plus 6. But 10 digit cannot be 4 or more. 10 digit cannot be 4 or more, because if 10 digit were 4, the unit digit will end up being 4 plus 6. Obviously a digit cannot be a 10. A digit is so called because it's a digit. A digit cannot be two digit. The digit is just a digit. It goes from 0 to 9. Digits are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are only 10 digits. This is not a digit. 4 plus 6 is not a digit, so it's not possible. The 10 digit cannot be 5, because if 10 digit were 5, because of the fact that the unit digit is 6 more than that, it will end up being 5 plus 6. Again, it's 11. It's not a digit. Which means the only possibilities are that your n equals a 10 digit of 3, which is a 30, plus 8, at 30, it can be, 39, or 28, or 17, and that's it. Those are the only three possibilities. That's all there is. In the case of 17, as you can see, unit digit is 6 more than a 10 digit. In the case of 28, the unit digit is 6 more than 10 digit, and 9 is 6 more than 3. But in our case, as far as we are concerned, we really don't care whether n is 39 or 28 or 17, because all we are interested in knowing is if n is less than 40, yes or no, to which the answer turns out to be yes, it is less than 40. It is less than 40 because in all of these scenarios it's less than 40. So the first statement does the job. First statement is sufficient. A, D, B, C, E. Because the first statement by itself works, the answer cannot be B, C or E. Answer would have to be either A or a D. Let's look at second statement, shall we? And if it turns out the second statement by itself is also sufficient, then the answer will be D. If it turns out the second statement by itself does not do anything, is not sufficient, then the answer will be A. Let's look at second statement. I need the room, I need a lot of room, I need to erase everything. Okay? I need to erase everything. I'll give you a chance to pause it if you like. Alright. The second statement is not that simple to analyze if you do not know exactly how to set it up. It says n is 4 less than 4 times the units digit. Now listen, before we continue with this video and before I completely forget it, this will be a good time for me to remind you that I would like you to watch math problems day 33. Just type in this tag, nothing else. Just type in math problems day 33 along with my name and you'll find some math problems that I have done that are on the YouTube, which I found to be interesting question, and this was one of those questions. In that problem, in math problems day number 33, we will learn how to write a 2-digit number. It seems like a simple notion, but the question is, how does one express the idea of a 2-digit number in the language of algebra? For example, let's take a simple example of 39. If we are told that the 10 digit is 3 and the unit digit is 9, the number in question is 39 because 10 digit is 3 and unit digit is 9. But how do we express that in the language of algebra? We can't simply write TU. TU in the language of algebra is just 3 times 9, it will be 27. TU in the language of algebra is 3 times 9. That's not how we write it. So how do we write it? What we have to understand here is that 39 is so called because it is made up of 30 and a 9. That's why it's called 39. 30 and a 9. Now how do you express 30 if t happens to be 10? Oh sorry, if t happens to be 3. If t happens to be 3, then 30 would be written as 10 times t. 10 times t is 10 times 3, which is 30, plus a u. So your integer would be 10t plus u. Let's do one more. Let's do one more here. Let's do 47. In this case, let's pretend that, not pretend here, our 10 digit is 4 and our unit digit is 7. How do we express it? We will express this as 10 times t, which is 10 times 40, 10 times 4, which is 40, plus a 7, which is our u. So this is how we express this: 10t plus u. 10 times t, 10 times the 10 digit, which is the multiple of 10, which will give us the multiple of 10. For example, 73 is 7 tenths. That's what we are saying here. In the language of algebra, we don't say 73. We'll have to say 7 tenths and a 3. Let's do it here then. So this n here, we are told, is 4 less than. Before we worry about 4 less than part, let's first write the n. N is simply 10 times t plus a u. 10 times the 10 digit plus a u. We are told that this quantity is 4 less than 4 times the unit digit. 4 times the unit digit is simply 4 times u, and it is 4 less than that. Let's simplify it. Let's bring the u's to the let's bring the u to the other side. So we end up with 10t equals 3u minus 4. Now what does this tell us? This tells us that this quantity, this tells us that the quantity 3u minus 4 is some multiple of 10, because it's 10 times t. You see, if you were to divide both sides by 10, t, which is an integer, would equal to 3u minus 4 over 10, which means this quantity 3u minus 4 has to be some multiple of 10. Has to be some multiple of 10. And what we'll find out is that the only value of u that will work is 8. The only value of u that will work is 8. I'm going to continue this on the top of the page there so that we can talk about it. I need the room, so I'm going to erase this part right here. Okay. The quantity that we're talking about, this part, 3u minus 4. Okay, I'm not going to write every one of them, I'm just going to go through them very quickly. Can u be 1? The answer is no, because if u were 1, 3 times 1 is 3, 3 minus 4 is not even a positive number, let alone being multiple of 10, it's not even positive. 3 times 2 minus a 4, 6 minus 4 is 2, which is not a multiple of 10. It is not a multiple of 10. It has to be a multiple of 10. 3 times 3 minus a 4 is 5, which is not a multiple of 10. It has to be, this quantity has to be some multiple of 10. 3 times 4 minus 4, 3 times 4 is 12, 12 minus 4 is 8. That's not a multiple of 10. 3 times 5 minus a 4, 25 minus 4 is 21, and that's not a multiple of 10. And you continue doing that, you will see that the only value that works is when u equals 8. Because when u equals 8, when u equals 8, 3 times 8 is 24, minus 4 is 20, and that is a multiple of 10. Voila! That is a multiple of 10. You see right here, rather, I didn't mean to circle this thing, I meant to circle this part. 10 times t equals, 10t equals 3u minus 4. So this is your 10t. And this equals 10t. And this one was 3u minus, this comes from here. It comes from this equation, 10t equals 3u minus 4. And that's 20. That's the only time when u is 8, that's the only time when you're going to find the value of the quantity 3u minus 4 to be some multiple of 10. And that turns out to be 20. Therefore, t is 2, because 10 times 2 is 20. And therefore, final answer is, we find out that finally, hence, our n is t is equal to 2, 10 digit is equal to 2, unit digit is equal to 8. The n is 28. The integer in question is exactly 28. So unlike the first statement, where we were able to narrow down the value of the n to 3 possible scenarios, we said the n could be, what did we say? We said that the n could be 39, or 28, or 17, and therefore, no matter what value it takes, is less than 40. In the second statement actually far more precise. It pinpoints the exact value of n. N has to be 28. It has to be 28 if it were to fulfill the condition. If it were to fulfill the condition that, well, I erase it. In the second statement, it tells us that n is 4 less than 4 times the unit digit. 4 times the unit digit, 4 times the unit digit is 32. 8 times 4 is 32. And 4 less than 32 is 28. There you go. N is 4 less than 4 times the unit digit. This is the only possible answer. This is the answer. When n equals 28, that is the only situation where 4 less than 4 times the unit digit is going to be n. That's it, we're done with this one. Because the second statement also works by itself, the answer is D. The answer is D. I'm very quickly going to do the problem that I skipped, problem number 7. problem number 74, which is a very straightforward, simple problem. We're just going to do it quickly, okay? We're not going to be as thorough, and we're not going to spend as much time on it. As I told you from the very beginning, we're going in reverse order. In 74, they're asking us, there is a point R that is given to us. Here is negative 1, 2, 3, 1, 2, 3. Here is negative 3 and negative 3. And then here is your positive 1 and negative 3. The question is point R, is R equidistant to A and B? I'm just going to call these A and B. Let's call this A and let's call this B. In the first statement they tell us that R lies somewhere. Sorry, they tell us in the first statement they tell us that the x coordinate of point R is negative 1. Well, negative 1 is right here. The equation of this line is x equals to negative 1. So it doesn't matter where, as long as the x coordinate of R is negative 1, what it tells us is that the point R lies somewhere along this line. And as long as it lies somewhere along this line, we'll find that it will be equidistant because it forms an isosceles triangle. It will form an isosceles triangle. This side is equal to that side. It doesn't matter where point R is. These are the possible location of R. It doesn't matter where R is. It will always be equidistant because it forms an isosceles triangle. So the first statement by itself is enough. AD, BCE. Because the first statement by itself works, answer cannot be B, C, or E. Let's look at second statement, shall we? In the second statement they tell us that point R lies on the line y equals to negative 3. Again, here are our points. 1, 2, 3. 1, 2, 3. Here is your point A. Here is our point B. Here is our point B. And we are told that R lies along this line. The equation of this line is y equals to negative 3. But we are told that the point R lies somewhere along this line, y equals to negative 3. Is that enough for us to tell whether point R is equidistant from A to B? The answer is no, it could be anywhere. R could be here, R could be here, R could be there, R could be anywhere. So the second statement is not enough. Second statement does not do the job. Therefore the answer is A. The answer is A. Alright? I don't think this question deserves us to spend too much time on it. It's a pretty fairly straightforward question. I'll see you tomorrow, okay? Bye now.